Yes. Yeah. Come on. It's on the counter, the little edge. Okay, so we are going to continue with complex trinomial factoring. Essentially, that's a special way of describing trinomials with the a value not equaling to 1. So take a look. This is number 9 from the text. A, 6x squared minus x minus 12. You can see that, right? Everyone? Take out a piece of paper. It's not just me doing the examples again and again and again. I'd like you to follow through. And at a certain point, hopefully, you'll be able to predict what's to come. Here we go. Step 1. So I'll call this, I'll do it little Roman numerals, okay? Step 1. I'm looking for two numbers. Okay, I recognize that the front number is not a 1, and I can't divide a 6 out of all 3. It's not a common trinomial, or a common factor. So I'm stuck. So I assume that this is in fact complex, and so we move on. I'm looking for two numbers that are going to multiply to 6 times negative 12. That is negative. You know what? Keep getting ahead of myself. I have to assume this is the first time you're still doing it because you forgot everything from yesterday. The A value is 6. The B value is negative 1. The C value is negative 12. All right. I need two numbers. So I have A times C, which is 6 times negative 12. That is negative 72. I need two numbers that will multiply to negative 72. And the same two numbers have to add to a negative 1. That's all step 1, and it's the hardest one. You have to set yourself up. And because there's so much sort of thought that has to go into it, that's why we call it complex. It's just a little bit more harder. So what are the numbers? I'll give you 30 seconds. Oh, go ahead. Yeah. Maybe, right? It is here, negative 12 times 6, but does negative 12 plus a 6 give you a negative 1? No. So it's not negative 12 and 6. I need two other numbers. It does not. It has to multiply to negative 72 though. So here is one strategy. If you're struggling, if you tried yesterday and you're really struggling, right? Write out all the factors of 72 or negative 72, okay? So it could be a 1 with a negative 72, or it could be a negative 1 with a positive 72. It could be a 2 with a negative 36. It could be a negative 2 with a positive 36. It could be a 3 with a, yeah. So it could be a 3 with a negative 24. It could be a negative 3 with a positive 24. You keep on going. And as Carter was saying, it could be an 8 with a negative 9 or a negative 8 with a positive 9. None of these, if you add it together, gives you a negative 1, except this one. How do I know? Well, you just try it. 8 added with a negative 9 gives me the negative 1. Check. Because, you know, if you do negative 8 plus the positive 9, you get a positive 1. That's not what I'm looking for. So you have to go through all of them. And the first couple of times you do it, you may have to go through all the products, especially if you're not that great with multiplication. But you'll start to get the hang of it with lots and lots and lots of practice. So we've established in step 1, the numbers we are looking for are 8 and negative 9. Great. Step 2. Take that middle term and break it into these two numbers we've talked about. What I mean by that is this: x squared minus x minus 12 is now going to be a positive 8x with a negative 9x. You might be thinking, why did you suddenly introduce those numbers? Well, take a look at this portion. The negative 1 here is going to be rewritten as if it was an addition-subtraction sentence or statement. A positive 8 with a negative 9 will equal a negative 1. That's step 2. Step 3. Take the first 2, take the last 2, and group them, and have a plus in between. Do not forget that plus. So let me write it out. We have positive 6x squared, positive 8x, plus a negative 9x minus 12. Yes? You can. I know exactly what you're saying. Carter was asking, does it have to be a plus 8 and a negative 9? Can it be a negative 9 and a plus 8? The answer is yeah, absolutely. If you want, I will do that for you on this side. Let's pretend this was 6x squared minus 9x plus 8x minus 12. Do you get a different answer? No, you get the same answer. I'll show you after. So continuing on, I might run out of space, but bear with me. Let me move this up a little bit. Okay. Here we go. Now that we have this, the rest is easy. Please common factor for me. 6 with 8. 2. X squared x is an x. So I can factor out 2x from the first bracket, leaving me 3x plus 4. From here, I can factor out negative 3. Please note that I say negative because I want to keep that x value positive. It's a good habit to have in my opinion. So try that, please. And then step 5, now that you have groups and we have two different a binomial here and a binomial here that are identical. How about I color code it with some blue? If you're doing this correctly, you will always get these two binomials equal to each other. I'll say it one more time. If you're doing this correctly, you will always see these two brackets equal. If these two are not equal, you stop right there. You're like, where did I go wrong? And you have to backtrack. Okay? So this is a good way to, this is your signal. Okay? This is when you know you did it right or not. Because here, you can factor out a 3x plus 4 out of both of them, leaving you 2x minus 3 done. And do you see, Carter, most likely you just have these switched, but the answer is going to be the same. For the sake of repetition, because we're going to be doing this all day today, that's all today is dedicated to, I'm going to do it the other way. Instead of plus 8, I start with a negative minus 9. Step 3, what do I do? In your own words, what's happening? Look at step 3 here. What am I supposed to do? Huh? Not yet, not yet. This is too messy. What's new in the next line from before? Right? What did I add in the next line? Oh, it wasn't a trick question. It's just these brackets. You take the first two, you group them together. You're sort of organizing yourself here. And then you group the next two. Remember, this is a positive 8, right? Minus 12. What's step 4? What you said before. There you go. So 6, 9. I'm going to factor out a 3 And there's also, of course, an x that I could factor out. This becomes 2x minus 3. How about this one? 8 and 12. The largest number I can divide out is a 4. And this becomes 2x minus 3. Again, take a look. Here's my signal. Am I doing it right? Those two brackets out. Let me just finish. And so I factor this out. This becomes 2x minus 3. And 3x plus 4 is the same thing. Yes, Jen? The 3x? Okay. The question was, how did I get from here to the next line? Well, 3x squared minus 9x. So this is common factoring. We did this separately in section 2.2, so it's part of the quiz. It's very important that you know, okay? Take a look at the coefficients and take a look at the variables. We're gonna look at each set and see if we could divide something out of both of them. So 6 and 9, I know that they are both multiples of 3. So I'm going to divide a 3 out of the entire thing. So 6 divided by 3 is 2. Right? What about 9? Negative 9 divide out of 3, you get 3. What I'm doing here is from trying to read your face with the mask on. What I'm trying to do here is the reverse of expanding. If I told you to multiply this out, 3 times 2, what does that become? Yeah. And 3 times 3, negative 3, it becomes negative 9. I'm doing the opposite. I'm dividing out now. I'm not quite done. I notice that there's also an x squared and an x. So these two terms both have an x value I can divide out. So when I do so, this becomes 2x minus 3. So I'm doing all that within complex trinomial factor. All of this has 2.1, 2.2, and 2.3 mixed in it. That's why it's the hardest one. It's like the final step. Now I'm going to do it again and again and again. Hopefully through repetition, you'll be able to understand. Any questions for number 9A? Because we're going to be going into the, I'm going to call it harder because these numbers are bigger. Okay. Let's try B together now. I'm going to clear this, but if you do want to refer back to it, of course, this video is being recorded, so you can look at our lesson once again. 8k squared, 43, and 15. Again, step 1, let's take a look at what numbers work. My A value is, here, I'll do it on the side so I don't have to. A is 8, B is 43, C is 15. And so A times C is 120, and the B is 43. I need 2 new numbers. Well, it may not be new, but I think it is going to be new. 2 numbers that will multiply to this 120, but the same 2 numbers are going to add to a 43. There is your challenge. And I'll pause the video here. It's important that you rack your brain and get some experience in trying to find these numbers. Try it now. Okay, so we've got ourselves a suggestion, 40 with 3. When in doubt, everyone, please try writing it out. Okay, 1 times 120 gives me 120. But if I add that together, it is not going to be 43. 2 times 60 will give me 120. But if I add this together, it is not 120. 3 times 40 gives me 120. But if I add that, hey, it does. So that's how you can go about these questions if you're stuck. I know it's annoying, but if the number doesn't come to you, then keep trying. So this is going to be 3 and 40. So step 1, 8K is going to be, oh, sorry, I guess that is step 1. Yeah. This part is step 1. So step 2. This is going to be written as 8K squared plus, I think it'll be nicer to start with 40. Because I know 8 and 40 are nice multiples. There it is. And let me do some highlighting so that you know where everything is coming from. Okay. Step 3. And please note, I'm gonna stop doing the step 1, 2, 3s. I'm just gonna work through them afterwards. But for now, it will help us organize our thoughts. Okay, the first 2 terms in brackets, the last 2 terms in brackets, separated by a positive, a plus. Now, next one, common factor. Yep. Yeah. Perfect. Yeah. And leaving, so 8 divided by 8 is a 1. 40 divided by 8 is a 5. K squared divided by K is K. And K squared, if you divide that out, it's gone. Next one. 3 and 15, I can divide out a 3. And again, once again, if you're doing it right, here's the signal. These 2 brackets will always be the same. And so here's part 5. That is, yes. Oh, no reason. No reason. I just sort of forgot it. To be honest, since you brought it up, even if I didn't have the bracket, it doesn't really change the meaning. The brackets themselves didn't really serve a purpose. I just wanted to help organize your eyes. Like, hey, AK came out, 3 came out, you know, sort of like that. And that's it. This is the final answer. And you were able to turn it into 2 binomials. Why the heck are we doing this? You'll see in chapter 3, we're going to actually use these, and it tells us a lot about if we were doing math with, like, you know, real life situations. It actually helps us a lot with finding things out. But we need to learn the tools first, unfortunately, right? That's it. Letter C is going to, yeah, I think it's a good exercise for us to do. Any questions with this? And I hope you're starting to see it. It's just so repetitive. It's not easy, but being repetitive, you know, it never changes. So I hope that you'll get a hang of it. Letter C. We've got 30r squared minus 85r minus 70. Here's a special one. Before you even start step 1, see if you can do this. Can you make your life easier by common factoring something? 30, 85, 70. What's a number you can divide out? This is where number sense comes in. You might recognize, look at the last digit of each number. Don't think too hard. It's a 0 or a 5. What number always gives you a 0 or a 5 as a last digit? Not 10, because it has to be a 5. So all these are multiples of 5. So I'm going to divide out a 5, which gives me, oh, did you? Oh, my bad. That's 17, and that is 70 divided by 5, 1, 4. So this question might seem like you had big numbers, right? It's like 30 times 70. I have to find two numbers that multiply to 2100. Like, no, that's not the goal. If you divide by 5, you can actually pretend that this question is just about this. So the 5 will always be there. Don't think that it disappears. The 5 will be there, but we're going to do our factoring with 6, -17, and -14. So my A value is 6, B value is -17, C value is -14. A times C happens to be -84, and a B value is -17. Ooh, what two numbers will multiply to -84, but happens to add to -17? Not easy. Oh, that's annoying. I'm going to give these numbers to you because it would have taken you a little while, right? It's not 1. It's not 2. Yeah. Huh? Yeah. It's not 3. 3 and 26. No. What am I doing? 3 and 28. But it is 4 and -21. So it might have been hard. When in doubt, always start from 1 and start trickling down to see if you could find the numbers. The numbers are, bless you. Let's do +4, -21, and -14. And I will highlight this once again so you know where it's coming from. Okay, so there lies the challenge. If you've done this enough times, you actually might be able to skip a couple of steps, but I don't necessarily recommend it. What would the final answer be? I'm going to pause this video. I'm going to give you a chance to try it because it's going to be the same steps again and again. Go for it. I'll give you a minute. Oh. Would it be too much if I said that was about the time that you should take on your test? That was about a minute. Okay. This part, finding the 4 and the -21, could take you a little bit of time. But once you find it, everything else should be really mechanical. So I hope you'll be able to get there, okay? So this becomes, right? So the bracket becomes 6r squared plus 4r plus -21r minus 14. And then if you common factor from there, you get 2r, 3r plus 2. From here, you get -7 divided out. You should get +3r plus 2. Some of you, because you had to divide out a -7, like a negative number, you might have gotten a little confused. But I hope this signal part told you that you have to do something more than just a +7. If you divide out a regular +7, you would have been left with a -3r, which is different from a +3r. So that would have been a bit of a flag saying, oh, I got to step back. And if you are successful, your final answer would be something along the lines of 3r plus 2 and 2x minus 7. Okay. Any questions? Pardon? Oh, I don't know why I wrote X. It's supposed to be an R. I don't know why that came out. But anyways, I just got so used to it. Okay. Let's do it again. I'm going to do number 9E. Number 9E gives us a bit of a break. And it's basically the same thing, but we'll see how many people catch on. Okay. Number 9E, I'm going to give you full reign, full control of how you might want to approach this. I want to see how attentive you were in class today, because there are different ways you can go about it. I'm going to count down as if this was a test. If this was put on a test, I'd probably expect you to do this in about 2 to 3 minutes, because it will be worth probably 2 marks. Okay. I'm going to pause this. I'm going to put timer of 2 minutes on the board. So while you were working hard, looking down on your desks, I wrote these 2 methods. Just from this, I noticed something, and I'll show you what that is. Method 1, seeing as how this is not a 1, you could have gone the complex trinomial factoring method by multiplying A times C. But using our previous example as a lesson, you may have noticed that 3 can divide out of every single number. So I can look at this as A times C is -84 and B is -6. I need 2 numbers that multiply to -84, but still add to a -6. Or if you common factor this, you would have gotten k squared minus 2k minus 8, which becomes a regular, easier, simple trinomial factoring. So this is what we did today in 2.4. This is from 2.3. So let's pretend you haven't studied 2.3. You're able to do the hard stuff, but you're not able to do the easy stuff. Okay. So let's continue on this way. What 2 numbers will work here? I say that is a 1, 2, 3, 4, 6. Not 6 and 12. 7 and 12. No. 8. Yeah. Correct. 72. Yes, that's because I suck. Wow. That's why the numbers weren't working. So then it's 6 and 12. The numbers would be 6 and 12. So we have 3k squared minus 12k plus 6k minus 24. And I think, Jen, you probably did 6k first. Yeah. Should I do that? Does it matter? Yeah. Not a problem. So we have 6k minus 12k. And then the first 2 terms are going to be bracketed. So we have 3k squared and 6k separated with a plus, negative 12k, negative 24. Common factor, I can take out a 3k, leaving me k and 2. I'm going to factor a negative 12, leaving me k and a positive 2. And again, there's my signal. Look at the 2 brackets. We have k plus 2, and we have 3k minus 12. If I want to go one step further, take a look. 3 and negative 12, I can common factor something from that. We have 3, k plus 2, and k minus 4. In case you're wondering why is that a little bit different, I just took this and I common factored a 3 out. It's nothing you haven't seen before, so I think you can handle that. So the final answer is 3 times k plus 2 times k minus 4. Take a look. If you caught this little trick thing, right, just from looking at our previous example, and you know that this is a regular simple trinomial factoring, what are 2 numbers that multiply to a negative 8 but we'll add to a -2. -4 and a +2. So the final answer is k -4, k +2, which is exactly the same as before. So no matter what route you decide to take, it's okay. You should get the same answer. That's it. This is 2.4. And you see it again, really repetitive, again and again and again and again and again. I hope to perform this by over tomorrow and of course over the weekend. I thought it might be prudent to try some of the questions you're familiar with, like number 7, the unknown k value. We'll do one. Okay. Actually, we'll do 7a and then move on with C, because C is hard. Number 7a from the text says, hey, if this is factorable, what's the value of k? So let's work backwards. If this is factorable, what did we do? A is the value of k, B is 4, and C is 1. What did we check? What did we check for step 1? If this is factorable, then I need two numbers that do what? Not sure. The same stuff. I need two numbers that do what? Well, it would add to 4 because B is 4. And the same two numbers need to multiply to k. And that's the puzzle. Give me two numbers that will add to 4. Yeah. If this is 2 plus 2 and that equals 4, the same two numbers, what would k be? 4. That's it. So k could be a 4. This is factorable. I know it because it fits that description. Give me another one. There's more than one answer. What two numbers will, add to 4? Huh? 3 plus 1. If it's 1 plus 3, then 1 times 3 is a 3. This, you can test it, but this is also factorable. So this is why, look, if you read number 7, it reads this. For each expression, name an integer. Name one number, one integer that would make this factorable. So if you gave me the answer 4, full marks. If you gave me the answer 3, full marks. Can you think of another example? What two numbers add to 4? Yep. Yeah. Well, so what's -2 times 6? -12. So if you gave me -12x squared plus 4x plus 1, you also get full marks, right? It's a completely open-ended question, but you're applying your knowledge of complex trinomial factoring. That's why it's an A question. That's it. So after today, we basically spent an entire hour just going through 1, 2, 3, 4, 5, whatever questions. And I know it's dreary, but if you get better at this, 5 questions in 1 hour will become 5 questions in 30 minutes. It'll become 5 questions in 10 minutes. It could be 5 questions in 5 minutes. I don't know, a minute a question. Depends on your practice. On the bottom of this sheet, as you see, I added more homework questions that you can try in page 109 in the text. right? Page 109, we've got numbers 2, 4, 5, 10, 13, and then 7 we already did, basically. You can try 7 again if you haven't done so already, but think of this as part of your test prep. Tomorrow, I'm going to be doing one more thing. There's a chapter 2.5 from the textbook. There are some special cases that I want to cover, just in case you get stuck. I think you'll find it pretty interesting. I think you'll find it helpful. And then Friday is going to be a test prep where I will remind you, please bring your textbook because I only have 4 here. Okay? And that's it. We have a test on Tuesday, but it will be all of the factoring stuff here. This chapter is all on the mechanics, the skills. Then we'll be using those skills in chapter 3. Yes? It's going to be 50 minutes plus extra time. So the 25 minutes extra time. Welcome. So what does that mean? Mark my words. You are not wasting your time investing your studies into chapter 2, because if you do, chapter 3 becomes incredibly easy because you're going to use chapter 2, right? If you don't do chapter 2 now, then chapter 3 becomes chapter 2 and 3 tests, and that's even harder. So start now and suffer now and be happy later, or suffer now and suffer later. The choice is obvious. Please do your best. Still got 15 minutes before the end of class. I really hope you will put this time or use this time as practice. Okay. Any questions?